This is the 122 Mark II that I was working on in a previous video. And I had a viewer send me a link to a audio news group where this deck became the subject of a bit of conversation because the original poster's sensibilities were offended that a guy would make some improvements on a machine that I guess he felt was unimprovable. There were some other comments in that thread, of course, also, some of them quite thoughtful. One in particular, I remember the guy actually took the trouble to suffer through a couple hours of my videos and then wrote a very accurate summary of what really happened and took place and why, my reasoning behind the decisions I took and the work I did. Another one that stood out as being thoughtful was kind of in the form of a question. He wanted to see the straight repro frequency response apart from using the recorded signal, because that can be tweaked to artificially enhance the high end. And not only is that 100% correct, but also the subject of the video I did a couple back on how doing that very thing, artificially enhancing the high end, increases the distortion beyond the acceptable limit, and why biasing a tape apart from the consideration of distortion is less than ideal on the one hand, and as the poster pointed out, can go as far as being disingenuous on the other end. So my intention at the time was to make a follow-up video and showing the repro frequency response following head lapping, and 8 or 10 months went by and I never got it done. So here it is finally. I'm using my GenLabs equivalent of an MTT 256 tape, which is the one asked for in the manual. Others can be used, but this is the one that I have. And I like to listen to Mr. Liskin's accent.
Section 2. Frequency response calibration. The next tone is a reference tone of 315 cycles per second. It is recorded at minus 20 decibels level.
And let me just point out that even though he says minus 20, it's actually at minus 24 dB.
Exactly minus 20 decibels level. Do not change the volume control hereafter.
Okay, so I'm just going to let this play through. What I normally do is just write these down while it plays through the tape. But now I've found doing it this way and showing it on video, it's a big benefit to just tape it.
Cycles per second.
Sorry, I stepped on that. That was 31.5 hertz.
40 cycles per second. 63 cycles per second. 125 cycles per second.
I'm not speeding through this. I'm just going to let you hear all of it.
215 cycles per second. 500 cycles per second. 1,000 cycles per second. 2,000 cycles per second. Four thousand cycles per second. 6,300 cycles per second.
Now, the microphone I'm using here is one meant for video conferencing. And so
8,000 cycles per second.
it's pretty unlikely that it will pick up any of these higher tones.
Ten thousand cycles per second. 12,500 cycles per second. 14,000 cycles per second.
And 14 is where this particular tape ends. Okay, so that's very good. I'm going to rewind this back because I've got one more deck I want to run this on. I do keep these calibration tapes tails out, so I have to rewind them every time I use them. We'll do some number crunching here in Excel. Okay, so spec-wise, what we're looking for, here's the page out of the manual, or the diagram out of the manual, using the MTT256 tape. We've got a plus or minus 3 dB from 63 to 10 kilohertz, and the datum is about 315. This is my spreadsheet, and about all I know how to do in Excel. There's the graph that Excel created for me, and I realized that the frequencies aren't as they are in the data, but I don't know how to make that happen. I tried for quite a while, and it's beyond my grasp. The actual data points are correct on the frequency, but I just can't get the numbers down here the way I want them. So I don't know. If anyone does know and wants to post a tutorial for me to straighten that out, that would be more than great. I spent quite a bit of time trying to get that, and I just couldn't figure it out. But what I can do is I can Photoshop and overlay and stretch and bend to get the amplitude correct and more or less the frequency, but there's so little deviation on that that it's insignificant for this purpose. So I did get 1 dB per division. I stretched it out to get the 1 dB per division on a minus 24 dB datum. And so what we're looking for on this is that line to be inside of that envelope. And obviously there's no question that the deck is performing very well following the head relapping and the other modifications. In the background there, while I was flapping my jaws about the Excel spreadsheet, I was running a recording. I was running the frequency sweep recording, and that first graph that was running in the background, or that first trace, was the monitor frequency response, which is also well within spec. And now this is the playback frequency response off the recorded signal. And it looks like I only did the one channel here for some reason. I'm not quite sure. Okay, well, let me just do a reset here and a fast forward and playback. Okay, so these are the monitor electronics, obviously. It's just the signal passing through the deck. And then rewind and playback. And this is the recorded frequency response. And this is a normal tape I'm using here. So there's the trace off the normal tape. Type 1. Okay, we'll just zero it out. Looks like I've got a base response down to about 31 or 30 hertz. Nice straight line going up to 16.5, if you want to consider just one channel the way a lot of them do. Maybe around 17, 16.5, 17. And that's the spec on the deck. I'm almost certain that's correct. And I've got extended frequency response out to 21. And this was all in the previous tape. I'm just going through this again quickly. But just showing the frequency response trace there. And now I'll do the distortion. So I set it at 2.1 kilohertz. And that will give me a distortion tone following the high-end frequency sweep that stops at 2.1 kilohertz. And of course I have to record it and play it back. See the meters deflect there to about -1 dB. That's the sensitivity of the type 1 tape. So once again, just to demonstrate that the bias wasn't tweaked to overemphasize the high end, which is a legitimate and authentic concern because that can be done. But it's at the expense of that distortion figure. And we can't hide behind that. So that's why I always do these two in unison. Okay, so here's the type 2 tape, TDKSA. I'll fast forward through this part. Okay, slightly higher distortion, but it can handle it. And we should gain about 1,000 hertz on the high end, and that's about exactly what we gain. And again, totally in spec. Maybe possibly just a tiny bit beyond the spec, but easily within the spec of the deck. Okay, so with all that done, let's do a noise floor test, signal to noise ratio, and I'll check the Dolby off, the Dolby B, and the Dolby C. And again, it's a 2-head deck, so I have to do the recording and then playback. So what I'll do is watch the counter, and at the 10 mark, I'll switch it over to B. And then at the 20 mark, I'll change it over to C. And then on playback, I'll do the same thing. All right, there you go. Got about 10 seconds of each. Now we'll just be looking at the numbers up here. Okay, so around minus 57, 58 dB, Dolby off, Dolby B in the 66, 67 range. Come on, left channel. There we go. And then Dolby C in the 72, 73, minus 73 range. And my test parameters are not exactly what they're looking for in the manual. They're looking to do the signal noise ratio test at 3% distortion level. And that's fine. I'm quite sure that this is within spec. And I think I do it at a more usable level. The other part of the thread that I'd like to talk about is the original poster bemoaning the fact that I changed out what had become an elliptical factory plastic capstan motor pulley with a precision machined brass replacement of around 10 times greater mass and commensurate angular momentum, and that there was no realized improvement because the deck is already rated at 0.04% wow and flutter. And here in the specification, it does in fact show 0.04. But you also saw at the top of the manual that it's a combination service manual for 3 different decks, 2 of which are belt drives. So if we scroll down here in the manual, hang on here just a second, I've got to try to reposition this. Zoom in on it. Stand by. Okay. What's this 0.06 here? What is this about? Well, this is the spec for the 2 belt drive decks. The other one is the spec for the direct drive deck. This is probably the most convoluted service manual in existence, and maybe not, but one of them certainly. So up here are the actual wow and flutter numbers on a belt drive deck that apparently I destroyed. And that was using my standard reference RCA wow and flutter tape, and here's the numbers off another one that I made off a completely different deck. This is just a homemade tape. Generally not as good, but that's a subject for a different video. And actually a pretty interesting video exploring complementary error, which I plan to do at some point, hopefully, if I have time. So hopefully this answered questions from that year ago or so video and audio forum thread. Hopefully my production quality's improved in that time. I certainly think I've learned a lot. And as always, I thank you for joining me. The idea for this video has been in back of the queue for quite some time, but I really did want to make it. I thought it would be interesting and informative, hopefully. So happy recording, and I hope to see you again soon.